Guys, this what you see is a 24 volts 3 amperes permanent magnet DC motor. So I'm going to use this motor to test its torque value with the setup that I made. This is the drill chuck with 0 to 10 shaft connectivity, and I have welded the metal piece to the drill chuck. So this drill chuck can adapt shafts from 0 to 10 so I can also test the motor torques with shaft sizes of 0 to 10 of course. Okay, now I had to change the motor because it did not have a base stand, so it was difficult to fit it to the vise. So if you need to fit a bigger thicker motor to a vise, you will need a bigger one. Okay, so this motor is in its place. I'm going to use this iron cable to connect it to the weighing scale, digital weighing scale, and the drill chuck. And the groove of the drill chuck is going to keep the wire steady and pretty tight. Okay, now when I'm going to power it up with this 24 volts 3 amperes power supply, the motor is going to start running, and it is going to pull the weigh scale, and the weigh scale is going to display the kg weight it is picking up. So guys, as you saw that the maximum displayed weight was 14.86 kgs. So the torque value is going to be 14.86 kg centimeter because the shaft welded to the drill chuck is 1 centimeter in radius. So guys, this is another motor, a little smaller one. Let's measure its torque. It showed somewhere around 12.64. So the torque value is also going to be 12.64. Today in this video I'm going to make a powerful inverter with these two power transistors CDC1351, okay, and this is the heat sink that I'm going to use for the job. So here as you can see that I have separated the single piece into two, although the pieces are not equal, but still this small piece is perfectly covering this power transistor completely, okay. Not a single portion is going to remain outside of the heatsink area. So yeah, even if it is not evenly cut, it is still going to work just fine. Well guys, I got this product from Banggood. It is very useful. You can see that it has like 4 arms for holding the PCBs, and link for this will be provided in the description. It is a high quality product, very useful PCB holder. And now it's time to do the connections. So guys, for that, these are the half watt 1 kilo ohm resistors, and I'm going to use 2 of these for this project. So guys, here as you can see that I'm connecting the resistor to the base terminal of this 1351 power transistor, and now I'm going to connect another resistor to the base terminal of the second power transistor. Okay, so that also done. Now guys, these 2 green wires that you see are for connecting to the collector terminal of the power transistors. Now guys, the middle terminals that you see, this one is the middle terminal of this transistor, and this one is the middle terminal of this transistor. These 2 terminals are the positive collector terminals, okay, to which these 2 wires will be connected. Now guys, I should tell you that this circuit is very important because this is the basic inverter circuit, and I'm going to use this to make a 1000 watts inverter in one of my upcoming videos. Yeah, and the collector also done for both the transistors. Now comes the resistor. One terminal of the resistor has been connected to the base, and the other will be connected to the collector terminal to which the green wire has been connected. Okay, yeah, done. This resistor has been connected. Now the remaining resistor. Yeah, both of them have been connected now. And guys, now comes the emitter terminal, the last one here and the last one here. These 2 will be shorted together with one single wire, which I usually prefer to be black, which indicates negative. Okay, so let's do that. Yeah, one terminal done. So guys, this is a 12 volts to 220 volts old computer UPS transformer that I'm going to use for this project. Okay, it's look very heavy, although the circuit is very small, but I have this transformer as the center tap transformer, which is applicable for this project. These wires, thick wires, indicate that this is the 12 volts high current input side. So this is going to be the 12 volt side, and these thin wires indicate the 220 volts side. Now out of these 6 wires, only 2 of them are needed. So how we are going to shortlist those is with the help of this resistance check. So the fine wires with highest possible resistance is the black and the blue wire, 12 ohms almost. So these 4 wires will not be used. So let's tape them together so that we can separate them. And guys, you also need to cut the wires from here, because they might cause short circuit. Here what you see is an LED bulb. Well, yeah, you see it's 5 watts Bajaj bulb. So I'm going to power it up with this circuit. Blue and black wire, which are the high voltage output side, will be connected over here like this, and here is the circuit. So the 2 green wires that you see, okay, these 2 green wires will be connected to the black and blue wires here, and this red wire with an additional point over here is the center tap. So this will not be connected right now. Let's connect one wire to the black. You can connect it anyways, like this one to this or that one to that, it doesn't matter. And yeah, that is also connected. Now in total we have 2 wires left out, one from the circuit, the emitter wire, final emitter wire, and one the center tap. So to the center tap, positive supply will be given, and to the emitter, negative black wire, negative supply will be given. And to power it up, obviously we are going to use this 12 volts battery, which is from an old UPS 12 volts 7Ah, and I restored it in my previous video. It was lying around for many months, and I restored it with the help of a laptop charger. If you want to watch the video, link will be in the description. So let's connect. You see this one is the positive, so red will be connected to the positive and the negative. And if the wirings are all perfect, it should glow. You see, it's glowing pretty good. No flickering, nothing at all. Works really nice. Simple circuit for charging mobile phones and you're running your CFLs or LED bulbs. And guys, you can even charge your cordless drill batteries with it. You see, this is my drill battery, 48 volts lithium ion battery, and this is the charger. Okay, so yeah, we'll keep it over here like this and connect the charger with a pin. One wire connected, now the other one also connected. Now when it starts working, you will see here the light glowing, indicating that the charger has started receiving power from the inverter. Okay, you see, it has started running and the battery has started charging. Well guys, here as you can see that this is the circuit and this is the transformer and this is the adapter for this Dremel tool. Okay, my Dremel machine. Okay, it is like 18,000 RPM adjustable. So yeah, at present it is in the off mode. So let's connect wires. Negative has been connected. Haha, you see it has started working. Well guys, here as you can see that I've placed a 143 nanofarad capacitor to improve the power factor. You see it is working. Today in this video, I'm going to teach you how to make an inverter. So let's start with the power transistor that I'm going to use in this project. Here you can see ST13009 power transistor. I'm going to use 4 pieces of these. Okay, if you don't get these or don't have these, you can also go for this MJE13009 power transistor. Works just the same. And I'm also going to use this circuit, inverter circuit, that I showed you in my previous video. If you haven't seen it yet, link will be provided in the description, so don't forget to check it out. These two are the big heat sinks that I'm going to use for this project. You can see that initially it was a single piece, but then I used an angle grinder and I split it into 2 as evenly as I could. It's from an old UPS. You can see a lot of oxidation on the surface of the heat sink. I will have to remove it here now. So let's start with that. Well guys, the surface cleaning process has completed. It's time to place the power transistors. The transistors, as you can see guys, are now well placed. Now guys, I'm going to install the full inverter setup on this wooden board. It's supply actually, and these are the heat sinks for the power transistor. One piece, yeah. Let's drill around 2 holes, one here, the other one on here. Next for this piece, one here, the other one here. Okay. So here as you can see guys that I have placed these nuts and bolts to keep the heat sinks in place. You see, just perfect. Now comes the connection part. Here guys, the 2 transistors on this heatsink are going to act as one big transistor.
and same for this one. This is one transistor, both will be connected in parallel, and these two also will be connected parallel. So the lowest terminal over here, you see this one, this is the base, you see, and this one is also base. So what I'm going to do is I'm going to move it like this. Okay, same for this one. Yeah, so here as you can see that I've bent the base terminal like this to connect them in parallel and separate it from the collector and emitter. Now base for these two, this one upper one is base for this one, and yeah, base, yeah, base, collector and emitter. So guys, here I'm going to use this green wire as base, which is this one and this one. I'm going to short these two. I'm going to solder them together. So guys, as you can see that I'm using green wire for the base, red for the collector, and I'm going to use black wires for the emitter terminals. Now guys, here I'm going to connect the black wire as the emitter. Okay, one terminal connected, second terminal also connected, remaining is the third and the fourth terminal or the emitter. Yeah, the last terminal has also been connected. As you can see, the last emitter terminal, of course the remaining three emitter terminals, all have been connected perfectly. Now guys, you've already seen this circuit. What I have done to this is I have removed the black emitter wire that was connected to these two. This one, it was connected like this, okay, and I have removed it because it is not needed in this circuit. So it's time to connect this circuit to the main circuit. So guys, the plastic has been stuck pretty good. Okay, now comes the time for connecting these two terminals to the heatsink transistors. Now guys, these two green wires are coming out from the collector terminals of these two transistors. Okay, the middle collector terminal. So these two wires will be connected to the collectors of the transistors of these two heatsinks. So this wire will be connected to this collector, which is represented by a red wire here, and this one will be connected to this heatsink transistor collector terminal, which is again represented by the red wire here. This is the red wire. I will have to stick it to this one. Now comes this piece. So the collector terminals from these two transistors have been connected to the collector terminals of the transistor on this heatsink and the transistors on this heatsink. Now remains the emitter terminals here. These two also have to be connected. Now guys, these green wires that you see, which I had connected initially, which represented the base of the power transistors on the heat sinks, these will be connected to the emitter. Okay, this much is the size. Again, this much is the size. So done. So the green wire is done. Okay, it's time to connect the green terminals to the emitter. Okay, yeah, this seems fine. Yeah, done. Now this one. Yeah, done again. So guys, the circuit is simple enough. This is the driver circuit involving no IC but only transistors and resistors, and this is the main high current handling circuit. Okay, it is responsible for taking high current from the batteries and giving it accordingly to the input side of the transformer. So it's quite compact and robust, and we are done with the making part of it. So starting with the transformer placement. Yeah, this seems fine. And about these wires, the black ones, big black wires. So to the thick black wires, these red wires will be connected, the collector wires. Okay, Let's connect it like this. It's not going in. Yeah, one connected. Now comes the other black wire and the other red wire. Yeah, that also done. So the collector wires have been connected to the transformer. So with that being said, let's place a battery. So again, I'm going to use this 12 volt 7Ah battery, because what's an inverter without a battery? I could use a 12 volts power supply, but this represents an inverter better. Okay, so starting the connections. First comes the positive terminal, this one. Okay, and the batteries are really used ones, like around 6 years or 5 years old. Anyways, the positive center tap terminal of the transformer has been connected to the positive terminal of the battery. The 220 volts output terminals are here, although these two wires are going to produce much more voltage, around 400 volts. But the good thing is that we have tappings here to control the voltage according to our requirements, and this being the negative terminal. So starting with the multimeter first, okay, pointing it towards 750 volts AC. Well, I've connected only one wire, and I'm not going to connect the blue one, okay, because I'm going to check it tapping wise, like the voltage is here and then here, then here and then here. This way you can see all the better. So connecting the wires, okay, yeah, inverter has started. I can hear the sound. So here you can see that it is producing around 68 volts AC, 130 volts AC, here around 180 volts AC, close to 220 volts. So this point should work the best. Okay, and this one is too high, 500 volts AC. That is why I said I'm not going to use this blue wire, because the voltage is too high. Okay, so you have seen the voltage. I will show you one more thing. What happens if I short the two terminals, or the spark level, whatever you may call it. You see, very high, very heavy spark. The voltage is very high. It is going to destroy our appliances. So not useful at all. At least for an inverter project, we need a max of 200 to 300 volts, not more than that. So guys, starting with this 5 watts LED bulb, Bajaj LED bulb. And guys, I forgot, if you want to watch the making part of this circuit, you can watch it from the link provided in the description. It is really important for the making part of this inverter. Okay, one wire, the white wire has been connected. The blue is empty, as I said, not needed. And let's start it and see how the bulb glows. I will have to touch it to this terminal, this one, because it produces 180 volts AC. Okay, you see, no flickering at all, glowing perfectly. But yeah, what's so great about it, because it's just a 5 watts bulb. A small inverter can also do that. So let's go a little higher. Well, how about this 18 watts LED bulb? That is pretty big. Let's try that. Okay, again to this terminal, not this one, because this is going to burn our circuit. Okay, great, perfect, good light. Let's turn off the lights and then try. Wow, pretty good. But then again, let's go a little higher. So guys, how about these? The celebration lights. Connecting one wire over here. And like turning on the inverter. Well, this might just shock me, because the insulation is not thick enough. Let's use this. Okay, this should do. Pretty good, right? I would really like to see, if I touch this terminal to this one, how bright it will glow. And this has no circuit at all. It is just, these are just incandescent bulbs. So let's try and touch it to this one, the 500 volts one. Whoa, once again. Oh, pretty bright. Nice. The inverter is working really nice, guys. So this was quite heavy load. Now again to an even bigger load. Well, let's try this bulb. Okay, yeah, Going to hold it like this, and see, glowing pretty good. Let's touch this one also to this terminal. It's going to produce higher voltage. Let's see if it glows brighter. Whoa, pretty good. Very bright. Well, now guys, let's go to the final piece of bulbs. 100 watts bulb, Philips. Okay, and yeah, I have a holder for this one. Okay, keep watching the screen, guys. It's very light, a little brighter. Little bright, more. Haha, full brightness. Pretty good, right? You see? Cool. Well guys, it was very bright, so I have turned off the lights to see how it works when there is no light in my lab. Okay, so trying that the final time. Now you can see that it is very bright. You see, it's a fully working, very powerful inverter, easily handling 100 watts load with a very old battery. The inverter is working really nice, guys. And there's one thing that I'm thinking about is while I've connected this blue wire, I'm going to remove this blue wire and connect it to this tapping point, because this one is this is the one that I need the most. It is producing 180 volts. Yeah, this one connected to this tapping point. Let's check it if the connections are working perfect. Yeah, perfect. Now guys, many of you might have already seen this one. It's a universal motor from a drill machine, 350 watts. So you might have watched many videos about inverter making, but this inverter is really special. It has no IC or microcontroller, but still the output is almost sine wave, because of which it can also run motors. You see? Well guys, you might have seen many videos about inverter. They like place a lot of transistors or MOSFETs or even ICs, integrated circuits, and then simply run a 60 watts or a 40 watts incandescent bulb and claim that it's a 1000 watts inverter or a 5000 watts inverter. But if an inverter can actually run an inductive load, a motor, then it's a good inverter, okay, as this one. So yeah, as you can see that it is working really nice.